Homework 10, section 5.3, independent events and the multiplication rule, video 5. I've written on the board, and I want to put it in a red box, the definition that we gave for independent in the previous video. A and P are independent if the probability of A equals the probability of A given that B has occurred. In other words, the probability of A doesn't change if I stick a condition on it. And by the way, you can work it in either order. You can say the probability of B equals the probability of B given that I put A as a condition on it. So the probability stays the same regardless of whether or not there's a condition on it. For example, let's say you draw a card from a deck of cards. Are the events D equals you draw a diamond and A equal you draw an ace independent? In order to answer that, there's a couple of ways we could do it. But let's say we start with the probability of drawing a diamond. We would need to know the number of diamonds over the total number of cards. Well, there are 52 cards total, and 13 of them are diamonds. So that reduces to 1 over 4, which is 25%. But we have to compare that to what happens if we say, oh, by the way, we drew an ace. And this is where you have to be careful when you're checking if events are independent. You start with either event, we'll say probability of a diamond. Then you compare it to the conditional probability of the same event sticking a condition on it. What's the probability that you drew a diamond? Think of it this way. What if I drew a card and I asked you what's the probability it's a diamond? By the way, it's an ace. What's the probability it's a diamond now? Is it still 25%? Well, if we use the number of outcomes approach for a conditional probability, the denominator represents the number of outcomes in the condition. So how many aces are in the deck? 4. Remember, I told you, my card's an ace, so it's 1 of 4 cards. In the numerator, it's the number of outcomes that are in common to diamonds and aces. So out of all 52 cards in the deck, how many of them are simultaneously an ace and a diamond? And the answer is only 1, the ace of diamonds. Well, 1 out of 4 is also 25%. And if you'll notice, the probability that my card is a diamond didn't change when I told you it's an ace. I drew a card, what's probability is a diamond? 13 out of 52, that's 25% chance you have a diamond. Oh, by the way, my card's an ace. Oh, well, in that case, out of the 4 aces, 1 of them's a diamond, and it's still 25%. Because the marginal probability equals the conditional probability, we can conclude that these are independent events. And it really wouldn't have mattered which one we looked at first. If you had decided, let's look at the aces first. Out of all 52 cards, how many aces are there? 4. 4 out of 52 will reduce to 1 over 13. But if we want to check for independence, we have to recalculate the probability of an ace, but now we have to impose the condition that it's a diamond. What's the probability my card is an ace? 1 out of 13. Oh, by the way, it's a diamond. Well, that changes things. Out of the 13 diamonds, there's 1 ace of diamonds. It's the only ace that is also a diamond. So it's still 1 out of 13, and we still draw the conclusion that these are independent events. It does not matter which one you consider the event whose probability you're calculating and which one you consider the condition. As long as you compare the probability of an event versus the probability of the same event with the second one imposed as a condition, then you'll draw the same results.